feel kind of sad without a class, so here's my new class of disturbing minifigs. I'm trying to represent all of you as I've seen you in various Canvas photos, and this is pretty much what I see when I look into the camera and look out at all of you. Pick your character.
In this video, we're going to build on some of the techniques that we saw in the last video having to do with metric to metric conversions. But what I hope to convince you of is this dimensional analysis technique that you saw in the last video is much more useful than just doing metric to metric conversions, and actually allows you to do any other kind of conversion, and sometimes even just help you to do a little bit of algebra. So the first thing we're going to do is I would direct your attention to the resource guide section of Canvas, where you should be able to find a file called Unit Conversion Practice. On there, we're specifically going to go over number 4, which hopefully will appear somewhere around here, like now. And we're going to show kind of how to do the dimensional analysis techniques when it's not just a metric to metric conversion. So here's that question. One of the things that's going to be the same is that we're always going to start with putting something over 1. One thing that'll definitely change in this video is we're going to start to talk about something called the derived unit. And so the 1 won't always be alone when we put it in that denominator position. But for now, we don't have to worry about that. What we're going to do is the same as we've seen before. We're going to put 84 with the units, put this over 1. We're going to leave a space for what we call the conversion factor, right? Some statement of unity, some equivalency. And we're going to allow the units to kind of tell us what numbers we should be putting in there. And as with any dimensional analysis, an important part is to kind of keep in mind where you're going, because a lot of these require several steps. Some parts are a little bit circuitous. You kind of go all the way, from one value to another value, and sometimes you kind of get lost there. So it's a good idea to just put that there so that you know kind of the where of, you want to end up eventually. So just like before, we recognize that anything that we put in the denominator is going to cancel out something in the numerator here. So I'm going to put my units as miles right here. And we're going to look over here and say, okay, is there somewhere that I want to go? And in this case, what we would end up with is this kind of weird looking conversion factor that somehow relates kilometers to miles. And I will say that the one-steppers are not so bad, because usually you've been given or can look up some sort of equivalency between these. And in this particular question, if you look at it, it actually tells you some information about a relationship between miles and kilometers. And so I'm going to put the numbers in, and I'm just going to mention one thing that has kind of confused students in the past. Also included somewhere in that question is this idea that there are exactly 0.6 miles in 1 kilometer. And so the key to understanding dimensional analysis is this idea that the numbers and the units all go together, right? And so in terms of understanding what numbers goes where, and ultimately what operation we're going to do, is it a multiplication, is it a division, right? Take your mind out of it, right? Just do what the numbers tell you you're supposed to do. So you see that this 0.6 goes with miles, and assuming you've set up your conversion factor properly, those are just going to copy directly over, right? So we've got 0.6 miles, right? 0.6 goes with miles. 1 goes with kilometers. You cross out miles, you do the operation, and what you'll actually notice is that we've got the math telling us that we're supposed to do 84 divided by 0.6. So I'll enter that into my calculator and write the answer up here. Okay, the hamsters in my calculator are telling me that the answer is 140 kilometers. One thing that I always do with my conversions, especially kind of back when I was new at it, I'd always do the sniff test, right? And you're like, what the heck am I doing? Well, it turns out what I'm doing is I'm sniffing this answer to make sure it feels right. And sometimes it takes a little experience to kind of develop your sniffer. And unfortunately, we're not in class for me to torture you with all the activities that would develop your sniffers. Yeah, maybe we could sniff some markers in class. That might make things a little easier sometimes. So what you'll notice is that I've got 84 miles. And if I look down here, I can see that, there's less miles value-wise than a kilometer, right? And so a mile is actually much longer than a kilometer. So what we should be seeing here is exactly what we saw, right? That number should go up, right? If I've set up my dimensional analysis properly, the fact that, I've got 0.6 miles in a kilometer, it should mean that I need a whole bunch more kilometers to equal the same amount of miles, right? And so it's almost like a ratio, right? You've got kind of the small number and a bigger number. Here we've got a smaller number and a bigger number. So that sniffs right. If I had screwed this thing up, that wouldn't be the case. So I did promise you that I was going to talk to you about one thing that kind of confuses students. And so what I'm going to do is I'm going to give you another conversion factor down here involving kilometers and miles. It's also going to be true. But it could have been something that was also given to you, and it leads to something that might be a little confusing. Okay, so here's a new conversion, right? It turns out that that is equivalent to what you just saw. The fact that there are 0.6 miles in 1 kilometer is true. It is also true that 1 mile equals 1.6 kilometers, right? And so we're not going to change too much here. In terms of the way that our units are arranged, but what will change is what numbers kind of go with what value. So what we're going to do is we're going to say, okay, now I've got a 1 that goes with mile, like that. Now there's a 1.6 that goes with a kilometer. It turns out, in this case, that the miles still cancel out, but in this case, we're going to end up doing a multiplication here, whereas last time we did a division, right? And so let's just do that and make sure that it ends up being the same value as last time. And there's our answer. We've got around 130 kilometers, right? I did round that number. And so the one confusing thing that really makes students not feel very good about some of these conversions is that, right, they'll look at my answer key where I used the last conversion and it'll say 140 and they'll say, oh no, I screwed it up, right? It says 130 here. Well, it turns out that has to do with these kind of like inexact equalities that we're using here. Really what we're saying is we should probably say that 1 mile isn't 1.6 kilometers. We should say that 1 mile is 1.609 blah, 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 right? Like a much more precise number. And when we use that much more precise number, and by the way, the other number we used wasn't very precise either, you can kind of get a little bit of a variation in answers, and that's something that makes students crazy, especially when you're trying to learn this stuff. So what I'll say is, first of all, just kind of go, okay, does it sniff right? Is this thing still consistent with what we saw before, right? A smaller number kind of leading to a bigger number. Yeah, it is, right? And it turns out, based on the methods that we were using, the precision of the values that we used in the last example, 130 is really about the same as 140, right? Where you can really tell the difference is if you screwed something up, right? That 140 that we saw in the last example should not become 5, right? For instance, right? So if you see a number that is just not, that just doesn't sniff right, compared to something you've done before, check your work first to kind of make sure that you're not fooling yourself. It turns out that that's kind of one confusing thing. Another confusing thing for students is that if you were, just like, I'm using the Breslin method all the way, right? So first of all, you should send me a check. Second of all, that method always said that 1 goes with the prefixed unit. And I've had a lot of students stop me and be like, whoa, wait a second, Breslin, that's not a 1, right? So that 1 going with the prefixed unit, that was something specifically for metric to metric conversions, which, let's face it, that's usually the type of conversion you're going to do in a chemistry class or any physical science class because the metric system is better and we very rarely use the English system or the standard system or whatever you want to call that stupidity. So don't be confused. If you see like a conversion where you're going from some sort of non-metric unit into a metric unit, that whole like one goes with a prefix number, just throw it out the window, right? That's really only useful for metric to metric type conversions. In here, we're going to let what the numbers are in the given conversion factor, right, dictate what numbers we put with the units. So I hope that kind of helps you a little bit. The next couple of video segments are going to just kind of develop that technique. We'll kind of make it a little bit longer, and then we'll go into something called a derived unit calculation. In this video segment, we're going to continue working with dimensional analysis, and I hopefully will show you ways that we can do any conversion that we've ever wanted to do. Say that you're, I don't know, a baker and trying to like upsize a recipe for, I don't know, the crew of people that just invaded your house. So what we'll see here is, first of all, we're going to have a multiple step kind of conversion, so that's going to make it a little bit more complicated looking. And also there's going to be a couple of different conversion factors that we're going to talk about. I should make one note about the lighting of these god-awful videos. I just had one of my cheapo Amazon lights die out on me. So if you're watching the lighting and thinking like, my God, it gets worse every video, I did just spend a little bit extra money to get a little bit better lighting in here. So you might actually see what I'm writing on the board and maybe not see this like really awesome, like Mad Max shade that I've got going on right here. Let's face it, you probably don't care much about me. You just want to be able to see the board. So I apologize for that. That's on its way this week. So other conversions. Shut up, Breslin. I heard you. What are we going to do now? Well, let's go to number 8 from that same exact sheet that we just saw. And I'll show you how to do a little bit more of a complex conversion. Okay, here's number 8 with all of the various given information. I've got a couple of conversion factors that I'm not sure yet how I'm going to use these. And I've got my conversion written right here, or what I would like to end with. So what I'm going to do is I'm going to go through and set it up exactly as I learned to set it up before. Numbers with units. This guy is going to be over 1. I am going to put 2 conversion factors in here just because I know that it only takes 2 conversions. Some might take 10, right? But not here. I know that this one's going to include 2. So what you may want to do is kind of expand it a little bit. And speaking of expanding it, I didn't leave any room for myself. So hopefully this is still going to be a halfway decent video. First thing we're going to do is we're going to keep track of all the units, and we're not going to think about numbers, right? Numbers make our brains hurt. So what we'll do is we'll say, okay, I've got miles up there. I'm just going to abbreviate it because I have no space. And I'm going to put miles there. And what I'll say is, did I get any kind of information from my glorious teacher that directly relates without me having to think inches and miles? You'll notice that there are no inches and miles like directly written. Of course, you could look this up on the Google and you'd end up with a couple of different conversion factors. But let's pretend we don't have the Google and we got to use these bits of information, right? Well, it turns out what we're going to do is we're going to use this yard much like we use the base unit in those more complex prefix metric to prefix metric things from the last video, right? Sometimes it's helpful to use kind of a middleman. So what we can do is we can now cancel out miles when we're all said and done. The problem is that I don't want to end in yards, so I need to put yards down here to get those to cancel. And then I recognized, well, wait, I have some sort of information that directly relates where I want to go to yards now, right? And so if I just plug in the right numbers, I'm going to end up with the right value here. And once again, I look at my units and I say, okay, what number goes with what? Well, I see a yard there and a 1760, so I'll put that up here. I see a 1 that goes with miles. I look up here and see 36 goes with inches and 1 goes with yard. So this is just helping me to kind of keep track of what I have to do. And I will say a lot of you that are pretty good at math or measurement and things like that, you might just say, like, why is he going through all this crap just to realize that he's got to multiply a bunch of friggin' numbers together? I can do that. Well, the problem is that eventually we're going to get to a concept in chemistry called stoichiometry, which depends on your ability to set these things up, right? So I'm kind of using this as a means to an end, and also something that can sometimes help you in life. I know it helps me when I try to like build my shed or something like that. Sometimes it helps to kind of be able to do some conversions here. And it hasn't fallen down yet, so I'm a success in life, I guess. So let me enter this into my calculator, see what spits out, and then we'll try one other one. My handy dandy calculator, which if it's correct, gave me that value, about 57,000 inches. Those of you that are into like significant figures and stuff like that are probably going to be pissed that I indicated too much precision to this answer. I doubt that you care that much. But anyway, about 57,000 inches. Again, we got to sniff the answer. Does it kind of make sense? Yeah, there's a heck of a lot of inches in a mile, right? So at least we got some idea that hopefully we're doing this sucker right. And so what we're going to try next is what I call a derived unit calculation. And it's specifically going to involve density because that's something we're going to do in labs quite often. In fact, I think your first lab or one of your labs has you do a couple of density calculations, and I'll show you how you can use dimensional analysis for that. This particular problem is from what's called the density worksheet, which is also available as a resource guide down below where you found this video. There's a couple of different, this is number 2, by the way, from the worksheet. And I wanted to show you how we can do a really common conversion that's required in chemistry. That's a type of question where you're given a mass, right? Or sometimes it's a volume, and then some information about the density. Lots of you all probably know how to do this algebraically. Probably after this video, I'll show you how you can kind of manipulate variables and stuff like that to do it algebraically. But since the majority of this is all about doing dimensional analysis, let's kind of see a way that using units can get you through a lot of different physical science concepts. I know when I took physics, like my very first year of college, I didn't have any idea how or what it meant, like my answers when I would calculate them. I would just use the units always and end up with the right answer. No concept of what the hell was working in terms of physics and concepts, but just being good at dimensional analysis got me an A in that class. So that means I'm an expert. Okay, right here, the way that we're going to start this is we're going to look at this thing, which I am going to call, we'll write it in red here, so hopefully you can see it a little better. A density, the fact that I've got a unit per another unit, like grams per milliliter, I think of that as what's called a derived, in quote, unit, right? And what I mean by derived is it's not just its own unit, right? It's kind of something that, involves a little bit of math just to kind of think about it. Another great example of this is miles per hour, right? That's another example of a derived unit. Anytime you say something per something else, so those of you in the health field, anytime you say like drips per minute, right? That's another example of a derived unit, which by the way, you can do all those calculations using dimensional analysis. Much more easily than all the craziness they teach you in like paramedic class and everything else. So, derived unit. Well, what does this really mean? Well, if you think about it, right, 5.45 grams per milliliter really is telling me a conversion factor. I know that if I measured out exactly 5.45 grams, I know that that is going to be equal to 1 milliliter. Right? That is no different than what we kind of saw before in terms of those other conversions. So anytime you see a derived unit, if this was in miles per hour, right, that would be the number of miles that you could go in 1 hour. Then you can convert hours or miles to kilometers or things like that, right? Derived units, the second I see something per something else, right, I usually write it out like this because I know, especially in a chemistry class, some sort of calculation is coming. So how are we going to set this up? Well, pretty much the same way that we've seen it before. We're going to put 65 grams over 1 we're going to put a conversion factor, and we're going to keep in mind where we want to go, right? We want to go to a volume, so that volume is going to be in milliliters. Of course, if we wanted to add an extra step and turn that into quarts or something crazy, we sure could, but let's not because quarts are stupid. Well, it turns out we can use these units now. We've got grams that we need to cancel out. We want to go to milliliters. We asked the question, is there anything that relates grams to milliliters? Well, friggin' dur, I just wrote it right there. So the numbers go with the units, right? There's a 5.45 that's going to go down here. The 1 is going to go with milliliters. Grams cancel out. We end up with milliliters. So this is telling us in order to get to the answer, we need to do a division. So let's enter that into the calculator, and I'll write the answer down. Okay, there's the answer that popped out, rounded, is so 11.9 milliliters. We're going to do that important step, which is to sniff the answer. And that kind of sniffs right to me, right? Because I know that in exactly 1 milliliter, there's 5.45 grams, right? In 10 milliliters, there would be 54 grams or so, and I got a little bit more than that, right? So that's what I mean about developing your sniffer. So next video, let's kind of see how we can handle something like this algebraically now. Same exact question, slightly different approach. So this has to do with the fact that we need to know the formula for density. And it turns out that density is always a mass over a volume. Right? Probably nothing surprising there. What I'm going to do, though, is I'm going to make these all variables. Right? I'm going to have a D, an M, and a V. And what I'm going to do is I'm going to do all my algebraic manipulation to solve for this value, right, which is V. And there's a couple of different ways to do this. And then I'm going to plug in the numbers. Lots of folks plug in the numbers first, and sometimes you kind of get confused by the numbers and everything else. Just something that I always like to do. And also you do this a lot in physics too, which has a lot more calculations that you don't care about, more than just this one. So we're going to solve for V. There's, like I said, a bazillion different ways to do this. But what I'm going to do is, since I've got a V in a denominator, or volume in denominator, what I'm going to do is I'm going to multiply both sides by V by doing that. And just like we saw in dimensional analysis, anytime one value is over another, it cancels out. And so what I've got at this point is mass is density times volume. And you might say, well, that didn't help any because we're given the mass. Well, now we just need one more step. We take both sides. We can divide by density. Density cancels out, right? Anything you do on one side, you got to do on the other. And so what you'll end up with is the fact that volume is equal to whatever the mass is divided by the density. And then, of course, what you'd do is you would plug in the 65 grams right here, and you would plug in your density right down here. You'd calculate it to be the exact same number that we ended up with last time. I'm not doing very good with board management, so let's erase some of this hunka-munka, and I'll just kind of put the answer up here. And if I'm remembering correctly, we end up with 11.9 mils. So just another way that you can kind of manipulate variables. I would say I find that a little harder than just doing a plain old dimensional analysis, but lots of you folks don't like using dimensional analysis. So here's just another way that you can do it.